Hello everyone. Today we will start talking about the reinforced cement concrete. Let's see what are the topics in this subject. First one is basic properties of RCC. Second one is limit state method, which consists of three subtopics, that is singly reinforced structures, doubly reinforced structures and flanged sections. Third one is working stress method, which consists of subtopics like singly reinforced sections and doubly reinforced sections. Fourth is the designing of beams and lintels. Fifth is the shear and torsion. Sixth is the bond and the development of length. Seventh is the slabs, one way and two way. Eighth is columns. Ninth is foundations. 10th is pre-stressed concrete. 11th is retaining walls. 12th is water tanks. 13th is staircase. 14th is earthquake engineering, and 5th is masonry structures. Let's see what are the references we are going to follow in this subject. First one is IS 456-2000, which consists of the designing of RCC structures, and we have also to consider the amendment 5 which has been done recently. Second is the IS 1893, that is earthquake resistant design of structures, and third is IS 13920, design and detailing of ductile RCC structures. Fourth is IS 3370 part 1 to 4, design of water tanks. Fifth is IS 1343, pre-stressed concrete. Sixth is IS 1905, design of load bearing walls. Seventh is SP 161980, design aids for the reinforced concrete, IS 456. These are handbooks. From 7, these are handbooks, and next one is SP 23 1982, handbook on concrete mix, and ninth is SP 24, explanatory handbook on IS 456. 10th is the SP 34, that is handbook on concrete reinforced and detailing. Let's start the first chapter, that is basic concept. As we know, the structural engineering has two parts. First part is analysis and second part is designing. The analysis part consists of two subjects, that is strength of material and theory of structures. Whenever we talk about these two subjects, we deals with compatibility, energy and equilibrium. And whenever we talk about the design part, we talk about the subjects like RCC, PSC and steel structures. The design part consists of safety, serviceability, durability, economy and the aesthetic parts. These parts have to be considered for designing. These things have to be considered for designing. And the next point is designing is always done on the basis of analysis of structure. That is, we first analyze the structure that how it has to be made, and based on that analysis we design the structure. First point is the safety. When we talk about the safety, that is, a structure must be safe with sufficient factor of safety for the loading that is expected to come on it during its design life. For example, designing of beams. It is made safe under the tensile loading by providing the adequate reinforcement. When we design the beam, we provide the reinforcement of steel within the beam so that it can be made safe. And next point is serviceability. Serviceability signifies that the structure should provide the service for which it is constructed, that is, its usability. It must be usable for what it is constructed. Example, doubly reinforced sections instead of singly reinforced sections is more serviceable. Suppose to explain to explain this line, suppose that the height available for the structure construction is limited. To carry out the desired functions, the structure must be made small, which is only possible if we use the double reinforcement instead of single reinforcement. That is, when we apply the single reinforcement, the structure size is slightly more, but when we apply the double reinforcement, the structure size reduces. If the available height for the structure construction is limited, we have to apply the double reinforcement. Next point is durability. A structure should sustain loading for which it is designed and should perform well within the safety limits and serviceable limits. This says that the structure must be made durable, that is, it can be used for very long time within the safety limits and serviceable limits. That is, the structure must be made durable but cannot be compromised on the safety limits and serviceable limits. Durability without serviceability and less margin of safety is irrelevant. Okay, for example, let's see one building constructed in the area where the outside environment and or the outside soil is full of sulfur. So for making the structure durable, we use the sulfur resistant cement. It made the structure durable, but if the structure could not sustain the load, it can be made unsafe. And if the volume of the structure becomes less than the required volume, then it's not serviceable. So we have to consider all the parameters, that is, it must be made durable but cannot be compromised on the serviceable limits and safety limits. If suppose the roof got bent but not fall, it is safe. It has not fallen. It is safe but not serviceable as the volume has been reduced. Okay, so we have to consider all the parameters simultaneously, that is, safety, serviceability, and durability. We can ensure durability to a structure by providing the nominal cover and selecting the specific type of material for the construction. Next point is economy. Design and the construction of any structure should be economical without affecting safety, serviceability, and durability. So, we can say that the structure must be safe and usable, that is serviceable, durable, that is we can use it for very long time, and fourth is we must make the structure economical, that is the structure should be made with the minimum cost. For example, casting was done when the casting was done, beam and the slab were used separate, but now the casting of slab and beam is done together, and this is called the monolithic casting. This method is more economical without compromising safety, serviceability, and durability. Next example is using pozzolana in some proportions with cement, which makes the cost of cement less. Fifth point is aesthetic. If the large investment is done over design and construction of structures, it must be made aesthetic, that is, good in appearance. Example, the changing geometry of the sections. If we change the geometry of the sections, it can be made more beautiful. And let's see the next topic, that is the plain and the reinforced concrete. In this, first point is the plain cement concrete, that is PCC. Paste, which is formed by the addition of water and in specific proportion in mixture of binding materials, that is cement, fine aggregates and coarse aggregates, and the admixture if required. That is, a plain concrete cement is a paste which is made from building materials, that is binding material, cement, coarse aggregate, fine aggregate, and add mixture if it's required. Second point is the concrete strong in compression but weak in tension. It is a property of concrete, that is, the concrete is always strong in compression but weak in tension. Next point is the tensile strength is increased by reinforcing it by the fibers, that is steel here, and it is termed as the reinforced concrete cement, which is called RCC. Its tensile strength is 1/10 approx of its compressive strength. Okay, then that is the PCC. What plain concrete cement has a tensile strength 1/10 of its compressive strength. PCC is generally used in the mass concreting, example dam. PCC has less strength compared to the RCC, that is why it is used only where no less strength is required, for example mass concreting, example dam making. Last point is, what is the meaning of reinforced? The meaning of reinforced is made stronger. Okay. Second part is the reinforced concrete cement. The concrete with the reinforced embedded in it. Embedded reinforcement make it capable of resisting tension. And the steel bars are generally used for the reinforcement of concrete. Okay. The steel bars are embedded in tension zone in the concrete and relieves it of any tension and take all the tensile loading without separating from the concrete. So what is reinforcement cement? The reinforcement cement is a plain concrete cement with the reinforcement of steel in it, which makes it more durable, more more strength, and relieves it relieves it of any tension and take all the tensile loading without separating from the concrete. The bond between the steel and the surrounding concrete ensures the strain compatibility, that is, the strain at any point in the steel and the concrete would be same. That is, the bond between the steel and the surrounding concrete is always made such that it's always strain at any point in the steel and the concrete would be same. The reinforced steel also imparts the ductility to the concrete, which otherwise is brittle material. Okay. So reinforcing the cement with steel makes it more ductile, that is, it reduces the property of cement of brittlity. Here, ductility means the large deflection of the yielding of steel would be observed prior to the failure. That is, the ductility provides early warning of failure of structure by the large deflection due to yielding of steel. The tensile stress in the concrete arises due to 1. Flexure tension, diagonal tension, shear, temperature difference, shrinkage effect, and sixth one is restraint or resistance to the deformation. These all topics will be discussed later. Under this condition, the reinforcement is to be provided across the potential tensile cracks. That is, when these tensile stresses occurs, we provide the reinforcement against the effect of these tensile stresses, which are the potential tensile cracks. Okay.